All right, in this video we're going to discuss the infamous event loop. Okay, so you've probably heard something about the event loop in JavaScript, and it all has to do with running efficient code in the browser while simultaneously making sure that your JavaScript is single-threaded, right? We've probably heard this lots of times, that JavaScript is single-threaded. So what does that mean? That means any JavaScript that you have written for your application, any standard JavaScript, if you're not using a web worker or something like that, is all running on one single thread. So it's synchronous. One thing is executing, then another thing is executing, then another thing is executing. Okay. Now this synchronous behavior is simple to understand, but sometimes you want to allow for multiple things to be happening at once. And with a single thread, that's hard to do. So we have to kind of interleave things together to allow for interactivity in our web browser. Okay. So while our JavaScript is technically single-threaded, so the JavaScript that we write will only ever be executing synchronously, that does not mean that the browser is single-threaded. Right? The browser can have other threads that are working, and in fact, the event loop, as you add items to this event loop, the event loop is what decides what JavaScript that you've written executes. The JavaScript that you've executed or you've written is executed synchronously on the one thread. Okay, but adding events takes place on a separate thread, oftentimes in browsers. Okay, so this concept of an event loop kind of takes this structure. All right, we load some HTML and load up a page. That technically is kind of an event itself, right? We are downloading something. When we get it back, there is a task associated with that element. So the element would be like a script tag, right? The event would be we've successfully downloaded it, and then the task is that JavaScript. So that task, we pop something off the event queue, we move the task up. So this task, think of it as just JavaScript, and then we move the task up here and we start executing our JavaScript. Now inside here we have a whole thing like the JavaScript call stack and just standard JavaScript execution, okay? But the task is just synchronous JavaScript that's executed. And then once that's executed, we can get rid of this event that has an associated execution context. Okay, so now our event queue is empty. Once our event queue is empty, then we can move on to timeouts. We can check to see if any timeouts are in operation. If we have one like this one here, we could check to see if the value has expired, right? The timeout always has some time in which it expires, but we'll start out and we'll just have this empty. So we skip this part, right? And then we render the DOM, right? So rendering the DOM is basically parsing any HTML, or if your JavaScript code adds elements to the DOM, right? The DOM is the document object model. It's what the browser uses to construct the visual elements of the website, right? So it parses HTML to construct the DOM, right? So the DOM is an object in memory that we can interact with. If our JavaScript interacts with this model in a way that changes the way things have to be displayed, right, then the web page has to update. That's called rendering. All right, so displaying the visual elements basically is what rendering is. All right, and then we check for more events, and we keep doing this over and over and over. So this down here is the event loop. All right, and most of the time we're just here checking for events. Nothing's going on. Okay, and what that allows us to do is just pause and wait for the user to click a button or to type something into a text field or something like that. So that's what we want. We want JavaScript to not be blocking. Okay, so we don't want a whole bunch of JavaScript to be running because we want people to be able to interact on the page. And if they click a button or they edit text, we don't want the page to lock up. It's a really bad user experience. Okay, so most of the time we're just sitting here doing nothing, and we also don't want our processor usage to spike. So right now I've got processor usage here on my 8 cores. It's kind of divided evenly, pretty low. If I had synchronous JavaScript running, like a while loop going like while true, this would spike and go to 100%. All right. If the JavaScript event loop was running some synchronous code, while true, that's going to take the entire thread, and we'll never get back to rendering the DOM or checking, right? So when we're rendering these DOM elements, you'll see me interact with a button, and I'm going to have something like this, like a while loop, an infinite loop. Not really an infinite one, but one that takes a long time. You'll see that normally when you click a button, there's a slight interactive behavior, right? And it changes the visual layout of the website, right? But if we're stuck on the synchronous task, the rendering never gets to occur because we don't get to go through this entire process. Okay, so in JavaScript, we want to keep our synchronous code, our synchronous tasks small, right? And always allow this loop to continue as fast as possible, right? If we have to break our problem down into different pieces, sometimes we can do that. There's something called web workers that will allow us to start a completely separate thread. That way this event loop is non-blocking. It stays free. So if we have a whole lot of complex calculations to do, we can do that with a different thread. Okay, that's with something called web workers. All right, so let's take a look at how this works in practice. So I've got from the last video, it's basically the same page, right? We have this event loop, and what I want to do is add a couple of buttons. All right, so these buttons are going to be one's going to be a synchronous delay, and the other one's going to be an asynchronous delay. Okay. And the sync delay is going to be 3,000 seconds milliseconds, and the async is going to be 1,700 milliseconds. All right. So for now, we can just leave it like this. But I do want to add a CSS, some CSS to this code to show you. You can kind of see it when I load this up. Let's load this up. When I hover over, you see just the standard way Chrome denotes interactivity of buttons. You'll see a slight color discolorization, right? So it gets slightly darker gray, and then when you click it, there's like a slight outline and it gets brighter. So we're going to make that more obvious. All right, so we're going to add button hover effect and button active effect. All right, and so this is going to give us whenever a mouse is hovering over the button, it turns green. Right? Let's reload. So when we're hovering, it turns green. Hovering turns green. When we go out, it goes back to normal. Okay, so there are these button states. And then the active state is when you click on it. So when I'm pressing down and it's activated, right? But we don't have our functions hooked up. But we still see the rendering of the HTML page is occurring, right? If we go back to our diagram, we see clicking this button, there is no synchronous code to run. It throws an error and allows us to continue rendering the DOM, right? So we see the discolorization as we have the different states of our button. We have a hover state, active state. So none of this hangs up, right? This is nice. We just don't have any actual synchronous JavaScript there to execute. All right. So what else do we want to do? We need to make these sync delay and async delay functions. Okay, so the idea here is I'm going to show the difference between synchronous code and asynchronous code and why it matters, and it all has to do with not blocking this event loop so that we can see how quickly I can move my mouse back and forth and this flashes, right? So that shows us how quickly the event loop is executing, and it's executing very, very quickly, but not as fast as like a while true. So it gives our processor some breathing room, right? We're not maxing out the processor trying to do this loop. We're checking to see if there are any events, and then we're pausing, right? And then we're checking back in a little bit of time, like a millisecond or something like that. Okay, so a millisecond, that sounds like a really, really fast loop, but it's really not, right? When we have gigahertz processors, right? So, kilohertz would be, thousands of operations per second, and then megahertz is millions, and then gigahertz is billions. Okay, so 1 millisecond, checking every 1 millisecond is not nearly as intensive as checking every single possible time the processor will allow you to. Okay. All right, so there's a big difference between having a loop that executes every single millisecond versus a loop that executes every single possible time it can when there's that the processor will allow it to. Okay, Those are two completely different things. And you notice this one here, we're not pegging the processor. Okay. If we have something synchronously running like a while true loop, we will peg the processor. So there's a huge difference there. And that comes into play when we talk about the event loop and the browser experience and the single-threaded nature of JavaScript. Okay, so let's make our functions sync delay and async delay. All right, so I've already written these out so we can save a little bit of time, but the idea is async delay is basically what you would expect. It's a timeout. Let me grab this code here. All right, so we're used to timeouts. And all we're going to do is we're going to use the performance.now and kind of measure how long it takes for the asynchronous task to end. Okay, so we're going to start it at a particular time, right? And then we're going to see that in the console.log. Then we have the set timeout. The set timeout just takes a function and then a delay in milliseconds. All right, so we're going to delay this long. And remember, with set timeout, this is asynchronous. The only guarantee here is that this code will execute not before this amount of time has passed. Okay, so we won't guarantee that it runs in this amount of time. We are just guaranteeing that it will not run before this amount of time. Okay, that's the only contract here. All right, so this is asynchronous, and again, we're using set timeout, which we're used to. This is creating a function with the fat arrow syntax, right? So this should all be pretty standard. And then what we're doing here is we're just taking performance.now and subtracting our starting time, and then taking the floor of that, and that should give us some milliseconds to tell us approximately how long this thing took to execute. All right, so that's the async. Now, how do we do a synchronous delay? We have to have some way of executing a loop continuously until a certain period of time has passed. So the easiest way to do this, we have the same setup, sync begin, just like we had async begin and async end. So we have sync begin, sync end, and we're keeping track of how long it took as well. But how do we know how long it took? We just make a while loop, and this is the condition of our while loop, and then the loop itself is empty. So we're just checking this constantly. We're going to check to see performance.now minus start. Is that less than the delay time? No. Let's check it again. No. Let's check it again. So we're constantly checking it as fast as the processor will allow us to check it. Okay. So this is going to peg the processor usage. Okay. We're going to see this spike. All right. And what we can do to kind of just test this out, we're going to do just a sync delay 1000, and then an async, after sync, and then after async. There we go. Yeah, I don't think we need these actually. All right, so we have the sync delay and then the async delay. Now, we'll just load up this page, sync begin, and then async. Okay, each one took 1,000 milliseconds. Let's pop back over and make this a little bit longer. Let's make it 2 and 2. 1, 2, 1, 2. Right, so about the same. It's like, okay, well, what's the big deal? All right, well, let's switch these. Let's say we have async and we want this to be 500 milliseconds. Okay, this is asynchronous, so this is non-blocking. When we do something like this, the set timeout basically allows us to run other JavaScript. This is the portion of the visualization here. Okay, so we're just periodically in the event loop checking to see if the timeout has expired, and if it does, then we run our synchronous JavaScript. That's completely different than executing something synchronously over and over and over until a time has expired. Okay, so if I do async delay 500, 500, these are creating two different delays. We could even say, this is a 600 one, and it doesn't matter. But then I'm going to do a synchronous delay right afterwards. So remember, the guarantee with this delay is that the function won't execute until this time has passed. It does not guarantee that the function will execute in this amount of time. So once again, we can run in the browser. We have 2 async begins. We waited 2 seconds for the sync timeout, right? But then you see our asyncs were 500 and 600, and they both executed about 2 milliseconds after this one, right? And there's our CPU spike, okay? That's because we never get to this part of the event loop to check the timeouts because we are in synchronous JavaScript. We're executing some synchronous JavaScript. We downloaded our script, right, and an event, right? And then we executed the element associated with that is the script tag. The event is like the onload event. We take the task, which is just the JavaScript, and we're executing our JavaScript here, right? So while this is executing, right, we've added the timeouts from these 2 functions down here, right? So we have 2 timeouts here. Oops. Screw those. All right, we create 2 of these async timeouts while we're still executing this task in synchronous JavaScript code. Okay, so then we go to the synchronous task, and this pegs the processor. All right, so this is a synchronous task that lasts 2 whole seconds, and so we never get, even though these durations are 500 milliseconds and 600 milliseconds, we have to wait for this loop to finish, which we've engineered to be 2 whole seconds. Then we get down to this timeout portion. Then we can see, okay, have these any of our timeouts that we're tracking, have their durations expired? Yes, we actually have 2 of them that have expired. So these go into the timeout queue, both at the same time because they both expired. And then we pull one out, execute the JavaScript associated with it, and pull the other one out and execute the JavaScript associated with it. So that's why we have this output in the browser, right? We started out async begin, and then the second async call begin, then our synchronous call, and we can't do anything. This pegs the processor. So that only took two seconds, but the 500 and 600 async calls had to wait because we pegged the processor, and we want to avoid that. Another thing to note is when we're running something synchronous, we can't render anything. You see how the colorization paused, right? The colorization is paused while we're running things synchronously. Okay, that's because the rendering is part of the event loop. So it's part of that single thread. All right, and when you think about it, it kind of has to be, because if JavaScript is single threaded, then if you're interacting with the DOM and adding things and removing things to it, the browser needs to have time to render those things before you can interact with it again, because depending on how you're doing that, you might retrieve something from the DOM that was changed from something previously in JavaScript, and that has to be synchronous, right? So if JavaScript is synchronous, a single-threaded synchronous application, then the DOM rendering has to be a part of that. All right. Okay, and then the last thing we want to show here is we can kind of remove this stuff. We'll make it fast. We'll go 200, 300, and then 800. All right. But what we want to get to here is basically, I'm going to click the sync delay. So that's going to be 3 seconds. Then I'm going to click async, and then I'm going to click sync, and then async, and we're going to see how long all of these things take. All right. So let's start with just sync and then async. So click, click. Now notice the rendering locked up. Sync begin, 3 seconds, and then the timeout did not begin until that entire 3 seconds passed. Okay, so why is that? Okay, we click the button. This is the synchronous event. All right, when we click the button, that is associated with the button element. The event is a click event, and then we started running some synchronous JavaScript. Okay, that JavaScript that we're executing was blocking, right? There was a while loop and it was blocking. But on a separate thread of the browser, I went ahead and clicked this button, the async button. Okay, so this is why it's important to understand that the browser actually does have multiple threads. The event loop is all just one thread though. Okay, so the browser went ahead and added, while this code was executing, another item to the queue, right? And then it comes down here. So as soon as our 2 seconds finishes executing, this is our synchronous code, right? That comes off, and then it checks to see is there anything else in the event queue, right? Before going to the timeouts. And it checks, and sure enough, there is. And so this is our async call that creates a timeout. So the task here starts executing, and all we do there is create a timeout. And by creating the timeout, that puts something in here. And then we're free to run the event loop until the second passes. And then eventually we find that the timeout has expired, right? So we can then pull this down and execute the synchronous JavaScript from this task. Okay. And then we go back to just the entire event loop executing over and over. All right. So that's why we get synchronous execution, right? 3 seconds, and then I clicked 1700, and then the async didn't start until the end of the synchronous call. All right. Now this is different than if I were to say, if I did it the opposite way. I'm going to remove this beginning stuff here. We actually don't need that. I don't want to muddy up the display. All right. So let's reload the page. I'm going to do async first this time and then click synchronous. Okay, so this is 1700. We'll click this by itself first. 1700 and 1700 milliseconds. So that's about right. So reload the page. Now I'm going to click this and then sync. Async, then sync. Okay, so we get this sort of, seems like an odd number, right? It's 3751, right? That's because when we clicked async, we set a timeout, and then about 3/4 of a second passed, and then I clicked sync delay. So we had already executed about 750 milliseconds, and then I clicked sync, right? And so then it executed 3 seconds. Now, I couldn't finish my async function, right? Because I was locked up in this event. So the 751 seconds that had already passed plus the 3,000 gives us 3,751, right? So it's not additive. It's not, if we added these two numbers together, that would be, 47,000 or 4,700 milliseconds, right? So it's not additive. It was halfway through this execution that we clicked this. Then we had to wait an additional 3 milliseconds, and then we could finish that. All right. So let's take a look. I'm going to click sync, async, sync, async. And I'll sync one more time. Notice how the display is locked up. And we got CPU spikes, right? Okay, so we're back. We can see that we're back because we have interactivity on our DOM. We begin 3000. I clicked async in there, right? But we didn't get to see async begin until after that. All right, so let's map this out again. We started with click, and this is a synchronous wait for 3000 seconds. So as soon as we click this, this goes onto the event queue. The browser puts this on the event queue. We pull it off, and we start executing the JavaScript, right? The task is a loop that runs for 3 seconds. During that time, we click another button on the browser, and it's an async call, so that gets added to the event loop. While this is probably still executing, I could have gone too slow, I'm not sure, but we click the other button, right? So we go back to a synchronous execution, and then we click async again. Okay, so this was our initial synchronous call for 3 milliseconds. This is async 1700, synchronous 3000. Sorry, yeah, these are it's 1 second, and then 1700 milliseconds. I'm sorry, 3 seconds, 3000 milliseconds synchronously. So this is going to lock the thread. This is an async 1700 millisecond. This is synchronous 3000. And then async 1700 milliseconds. Okay. So let's do this again. 1, 2, 3, 4. So that all should be under the 3000. Then async begins, and right away sync begins. Okay, and we didn't get our asyncs to finish until after the synchronous call. Okay, so sync begins, right? That first sync ends. That's when our first async begins, but we can't finish. We have another event, right? So sync begins, we get done with that. This is our async event, so that sets up a timeout. Then that's off. Now we have another synchronous event that comes up here, right? And so this is executing for 3 seconds. This comes off, and we can't go down to do this timeout, right? Because we still have an event here. So this comes off, and we start our async event for 1700 milliseconds, and that gives us another set timeout. All right. Then once this is off, then we can go through and do the timeouts. The timeout that was first executed, right? This one up here before the second synchronous execution. This timeout executes first, right? Because it's 1700 milliseconds have passed, but the other 1700 did not right away. So there was a pause here, if you noticed. We can do this again. So we'll see the first async finish and then a 1700 millisecond pause. See, there's the pause, and there it shows up. Okay, you can do it again. I'm going to go sync, async, sync, async, sync. So async begins, another async begins, 2 asyncs end. Oh, I need to do one more async. Okay, sync, async, sync, async, sync, async. I think I hit those. Okay, so we saw these 2 asyncs ended almost simultaneously because they never had the opportunity to finish because there were 2 $3,000 or 3,000 millisecond waits before we actually got to. Actually, there were 3 of those, so there was 9 seconds we had to wait. Okay, because we started with a sync call and then we went to async, right? So this had to wait 6 seconds, and then the second async call started and had to wait 3,000 milliseconds, right? 3 seconds. So these are the async calls, and then the final one was executed. Then it had to wait 1700 milliseconds to execute again. Okay, so it seems simple, but it's also a little bit complicated, and this is a great program to kind of test around and play with how this stuff works. And it's really important to your understanding of JavaScript. Again, this little diagram of the event loop that I've written, it's actually quite a lot more complicated than this, but this is good enough to kind of give you a good understanding of how things work. All right, let's see, is there anything else? No, I think that's it. So that's good enough for this video. Just keep in mind the concept of the event loop as we go forward.